So this is the part 2, further explanation for the eigenvectors. In last video we talked about taking a wind turbine blade and taking some discretized points on the wind turbine blade, about which we want to find the effect of force, how our force gonna displace these discretized points. So before applying the force, how would we represent any point of interest on our original XY coordinate system? So we represent any point of interest with its X and Y value. So let's say you found your eigenvectors E1 and E2. Now there would be some points along this direction who would have a simple effect of your force, that is basically along these E1 and E2 directions your points would be getting stretched or compressed. So those points who would not be lying on these x E1 and E2 coordinates or the eigenvectors, they would be getting stretched or compressed and rotated as well. So how would you use these E1 and E2 eigenvectors to find a solution for those points? So we would represent those point of interest x with E1 and E2 now. Now these E1 and E2 would act as new coordinates or the solution coordinates. So how would you write it? So you would write it as any point of interest is equals to C1 E1 plus C2 E2. C1 and C2 are just scalar constants. So you apply the transformation, f is equals to A of x, and A is the transformation that's gonna change or displace your points from its original position. So you multiply the right hand side with A as well. And every eigenvector would have its own eigenvalue, that is lambda. So E1 would have its own eigenvalue lambda 1 and E2 would have its own eigenvalue lambda 2. So let's say your problem has more than 2 eigenvectors, so those eigenvectors would also getting added to your this equation. So these, now this solution Ax is equal to C1 lambda 1 E1 plus C2 lambda 2 plus E2, they would also rotate as well as compress or stretch your point of interest, or these discretized points. These are not lying on these E1 and E2 directions or eigenvectors. So the solution for any point x that is not on a principal axis or eigenvector direction, so is a linear combination of the principal axis solutions. And that's the case for steady case. Let's say your force is changing and then your eigenvectors may change, so you would have to go through this whole process again to find these eigenvectors directions or new solution coordinates, so that you can easily find the solution for other points or the discretized points in your space. So this is how you visualize them. Now